Example 7.7. Lights of two wavelengths 560 nanometer and 420 nanometer are used in Young's double slit experiment. Find the least distance from the central fringe where the bright fringes of the two wavelengths coincide. Given d is equal to 1 meter and small d is equal to 3 millimeter. Now what are the things given here is the wavelength of two lights is given. So the wavelength of the first light is lambda 1 is equal to 560 nanometer and the second light is lambda 2 is equal to 420 nanometer. Okay. Now we have to find out the least distance from the central fringe where the two bright fringes of the two wavelengths coincide. Okay. Now here the distance is d is equal to 1 meter and small distance d is equal to, that is the distance between the slits, that is 3 millimeter. Now here both are the bright fringes. So we can go for the equation of the bright fringe. Okay. So equation of nth bright fringe. So yn is equal to n lambda d by d. Now here the order of the fringes is not given. So we can take one is a longer wavelength and another one is having a shorter wavelength. That is 560 is a longer wavelength and 420 is a shorter wavelength. So we can take the order for one as n and the another one as n plus 1. Okay. So we can write nth order bright fringe of longer wavelength coincides with n plus 1th order bright fringe of shorter wavelength. Okay. So we can go for writing. So here the nth order is coinciding with n plus 1. So we can write, for nth order we can write n lambda 1 d by d, which is equal to n plus 1 lambda 2 d by d. Both are coinciding. Okay. Here lambda 1 is greater than lambda 2. So here d and d will get cancelled. Capital D and capital D will get cancelled. So what will we get? N lambda 1 is equal to n plus 1 lambda 2. So we can write lambda 1 by lambda 2 is equal to n plus 1 by n. So this can be written as lambda 1 by lambda 2 is equal to 1 plus 1 by n. Okay. Now you know the value for lambda 1 and lambda 2. So 1 plus 1 by n is equal to, what is the value of lambda 1? Lambda 1 is 560 into 10 raised to minus 9 divided by 420 into 10 raised to minus 9. These are the values of lambda 1 and lambda 2. So if you cancel this and this will get cancelled. If you cancel this and this, you will be getting it as 4 by 3. So you will be getting 4 by 3. So 1 plus 1 by n is equal to 4 by 3. So what is 1 by n? 1 by n is equal to 4 by 3 minus 1. So that is equal to 1 by 3. So what is the value of n? N is equal to 3. We have found out the value of n is equal to what? 3. So what you can write? The third, n is 3. So the third bright fringe of lambda 1 coincides with n plus 1 is what? 4. So the fourth bright fringe of lambda 2. Now what do you have to find out? The least distance. That is the distance between these two fringes. So how to find out the least distance? So yn is equal to n lambda d by d. N lambda d by d. So yn is equal to, n value is, you can write it as what? 3. 3 into lambda value. So the wavelength for the third bright fringe. We have to take the lambda wavelength for the third bright fringe. That is 560 into 10 raised to minus 9. Into what is the distance between the source on the screen? That is 1. What is the distance between the slits? That is 3 into 10 raised to minus 3. So if you cancel this and this, you will be getting it as 560 into 10 raised to minus 6 meter. So yn is equal to 0.560 millimeter. It's 0.560 what? Millimeter. So that is the least distance from the central fringe. Okay.